Today we're going to discuss limiting reactants. So I want first to just give a general idea, and the name kind of tells you what we're talking about, but basically if you have two reactants and one gets used up and there's none left of it, then the reaction stops. The reaction cannot proceed to make products if it uses up one of the reactants. So if you have more of a reactant than another, then if one gets used up, that's your limiting reactant. Okay, the one that gets used up or completely used is called the limiting, and the other one is the excess. So we think about this in just sort of a real life terms here. If we have bread and sandwich meat and we want to make a sandwich, if we only have 3 slices of meat, we can only make 3 sandwiches. And so here we have 8 pieces of bread. So we need 6, right? 6 of those to make 3 sandwiches. And then we have 2 left over. Okay, so this is an example of the meat would be our limiting reactant, because after we run out of meat, we can't make any more sandwiches. It's done. Okay, so we're going to look at 2 reactions because they are quite different, because this one is a little bit simpler, I guess, because this reaction we have a 1-to-1 ratio of our reactants. Okay, so we have to think about that when we are coming up trying to figure out what's our limiting reactant. Okay, so what you do here in this problem, we're given 10 grams of nitrogen and 10 of oxygen, and we want to know which one is the limiting reactant. Okay, so what you do is you convert your 10 grams that you were given to moles. So we go from grams to moles, just like we've been doing, dividing by the molar mass. So add up into, you get 28.02 from the periodic table. O2 is 16 times 2 from the periodic table, and that's all out of 1 mole. Therefore, here we get moles and moles. Okay, so in this problem, we have a 1-to-1 ratio. So really all we had to do was just look here and say, okay, well this is more and this is less, so this has to be my limiting reactant. Okay, but I want to show you, just so you don't mess up on reactions, that you have maybe a 2-to-1 ratio or you have a different ratio. Okay, so what you really need to do from there, if you have 3.57 moles of N2, what you're looking at is which reactant limits you from making product. Okay, so what you would do is take your moles of N2 and go ahead and convert to moles of product. Okay, so we go from grams to moles and then to moles. Okay, and we do this by way of our equation. So we have 1 mole of N2 for every 2 moles of NO. Okay, because we have a 1 and a 1 here, it's not going to change anything. So we could have just done this one step and that be that. Okay, but if you do that calculation of 0.357 times 2, get 0.714. Uh-oh. Okay. If you take 0.313 moles, we have 1 mole of oxygen in our balanced equation and 2 moles of NO. So this second step probably seems sort of pointless because basically it doesn't really do anything except for 313 times 2 equals 0.626 moles. Okay, but what I'm showing you is that instead of just stopping after converting grams to moles, we went ahead and converted from moles of N2 to moles of product, because that's what you want to know. What are you limited by with respect to producing more product? So if you look here, it's still the same. So if we take that number and we multiply times 2, we have a 2-to-1 ratio. And we just so happen to have a 2-to-1 here as well because both of these were 1-to-1. So we get 0.714 and 0.626. So no matter what, oxygen is still our limiting reactant. Remember, your reactant is on the left of the arrow. Okay, so oxygen is our limiting reactant, and we could produce only 0.626 moles of NO. Okay, that's what's important here, is that because we're limited by oxygen, okay, that's how many moles of oxygen we have. But of product, we can only make 0.626 moles of product, okay, versus 0.714. We're not going to make 0.714 because when the oxygen runs out, the reaction stops. So you have to, whatever the smaller number is, we can only make as much as we have of both reactants. Okay, so I just want to walk you through another example here, and I just pulled this from a different place, so not really example 3.8. Okay, we want to know the maximum amount of sulfur dioxide, okay, so product that we could form if we were given 95.6 grams of one reactant, CS2, and 110 grams of the other. Okay, so what we can do is convert from grams to moles to moles to grams. Okay, so we take what we're given, we convert to moles of it, then we do a mole to mole ratio, and then we go to grams of SO2. Okay, so this is grams to moles to moles to grams. We take 95.6 grams and convert to moles by using the molar mass. And then we plug in our mole to mole ratio in step 2. We have 1 mole for every 2 of SO2. And then we convert, so this is grams to moles. Here's our mole to mole ratio. And then we convert from moles to grams of SO2 by using the molar mass of SO2. So we add up here and we get 161. So all this is going from grams to moles to grams. Okay, if you need to review that video, please do. Okay, you go from grams of what you know to grams of product. Okay, we're given another number here. We're trying to figure out which one of these is our limiting reactant. So we take our 110 and we convert from grams to moles of oxygen to moles of SO2. Notice these are the same. We're going to the same product here. Right? And we get 147. Okay, so based upon what I said earlier, okay, how much product can you form? Okay, the answer is you can only form 147 grams of product because oxygen here is once again our limiting reactant. Okay, so there's a difference here. Oxygen, not SO2, okay, not this number, okay, or this compound. Oxygen is our limiting reactant. Remember, it has to be one of these two. These are the reactants. Okay, oxygen is our limiting reactant, and we can only produce 147 grams of SO2. We can't form 161 grams of product because we run out of oxygen. Okay, and so you can only make as much as you have of both of your reactants. So the answer here is that the maximum mass of sulfur dioxide we could form would be 147 grams. And then if this asks what was the limiting reactant, the limiting reactant is oxygen. So all you do if you're given two numbers, two reactants, and you want to find the limiting, you convert grams to moles to grams, okay, and then you compare the two numbers. Okay, in the previous problem, we weren't asked for the mass of the product, okay, so all we had to do was just compare our two numbers and look at the moles, and that's fine. So if you're just asked for the limiting reactant and didn't ask you how much you could produce, then you could just find your limiting reactant this way. Okay, and here we had a 1-to-1 ratio, so this step really didn't do anything as far as changing our limiting reactant. But here, for every 1 mole of CS2, we had 3 of oxygen. So we had to have triple the amount of oxygen. Okay, and so obviously we don't, therefore we're limited by it. All right, I hope this makes sense, and let me know if you have questions. Thank you.